Okay, so hello and welcome to today's session on developing maths in T-levels. This session is aimed at teachers and assessors of the Education and Childcare T-level, and I'm hoping that you'll complete the session activities and take away a positive attitude towards a subject that I absolutely love. If you haven't already done so, please put something in the chat box to let me know you can hear me okay. It looks like Janet's got the sound now, so excellent. You'll find this at the bottom of the webinar control panel on the right-hand side of your screen, and also the session is being recorded and will be shared on our YouTube channel afterwards. So as per normal for all our sessions, we encourage input and questions from participants, so please add your ideas and any questions in the chat box as we go. So my name's Helen Scanlon and I'll be facilitating today's session. I'm one of NCFE's curriculum officers, and if we haven't met yet, I'm responsible for supporting the teaching and learning of the Education and Childcare T-level. We're also joined today by Janet King, the Sector Manager for Education and Childcare, and hopefully we'll be bringing Janet in for the subject-specific input and answering any questions. We'll also be completing a range of activities, including polls today and the sharing of ideas and experience in the chat box. And you can see the objectives of today's session on the screen now. The session will focus on exploring practical ideas and activities teachers can use to develop students' math skills, knowledge and confidence in the context of education and childcare. We'll also consider strategies which help to engage and motivate students in maths development, highlighting their importance for T-level success and, more crucially, how the skills will be used in the workplace and industry. Janet, I'm just going to say a quick hi and get you to do a sound check.
Thank you. I think I'm okay now. Hello. Hello, everyone. Hi, Helen.
Brilliant. Yes, you're brilliant. Excellent. Thank you. Thanks, Janet. So we're going to start off today with a couple of polls. The first question relates to the importance of math skills to you as a T-level teacher or practitioner. How important do you consider math skills to be? I'm going to launch the poll now, and please choose the most appropriate answer. This is not a test. Please answer truthfully, as I'm aware that not everyone believes that math skills and knowledge are vital for success. Lovely, thank you. We've got people voting for us now. I'm going to leave it just a little bit longer. Okay, I'm not going to share it. That's okay, Molly. We've got 50-50 split between extremely important and extremely unimportant. So that's a great start. Thank you. We're going to move on to the second question now. How important do you think the students consider math skills to be in the education and childcare T-level? So we've already looked at your attitudes towards it. Please now tell me what you feel your students' attitudes towards math skills in the education and childcare T-level to be. Lovely, thank you. I'm just going to leave it a couple more seconds. Okay, lovely, thank you. So I'm going to close that poll. We've got 2/3 saying not very important and a third saying quite important. So thanks for that. That's what I would expect. We'll have nobody saying that extremely important and nobody saying that extremely unimportant. So that's really interesting to see, and we'll kind of keep that in mind as we go through today's session. I'm going to start off by briefly running through my take on maths learning, as I've been a vocational technical teacher and also an English and maths specialist. So I'm going to share my thoughts. So I believe that learning maths is like building a wall. We start off learning the basics and then move up the wall, building our wall and our wall of knowledge and understanding. The skills then becoming more complex as we build. As we progress through our maths learning, we apply simpler rules to more advanced problems. And what I mean by this is what we learn when we learn how to add and multiply, we then use these skills later on to calculate perimeter, area, and volume. But what happens if we don't get a concept being taught or miss a lesson or lessons altogether? If the teacher doesn't check that every learner has got it and simply moves on, there is a chance that the learner could get left behind. We then have a missing brick on our wall of maths knowledge and understanding. And this can happen more than once. And if more new concepts are not fully understood and more bricks become missing, the teacher continuing on with the learning, but the development of skills being reliant on each other, and if the learner could not carry out a more complex calculation because of missing previous knowledge, they can't complete the harder tasks and could feel totally lost. We've now reached quite high up the wall and we've got quite a few missing bricks. So how strong is our maths wall of knowledge? As a maths teacher and adults, I found that my first job with a learner was to find out if they have any missing bricks, identify which skills are missing, and then teach them to allow the learner to make sense of the maths, which skills they need to have, and when to apply them. So to summarise, my take is that maths learning is sequential, reliant on having an understanding of the basics and then how to apply them in different and more complex situations and problems. So my next question to you is, which math skills are important in education and childcare? Please put your ideas into the chat box. I'm going to read through what ideas are coming in. So which math skills are important in our industry? So no answer is a silly answer here. So and you don't have to be very, very detailed, but just please let me know which skills you think are important in relation to maths in education and childcare. So lovely, we've got being aware of the curricular expectations, absolutely. And we're talking about not the T-level curriculum here, we're talking about early years and foundation stage curriculum, aren't we? So absolutely, so the skills that the young people they're going to work with are going to need, and yes, EYFS curriculum. Anything else in particular to maths specifically, rather than a curriculum area? Absolutely, ideas to make maths fun, absolutely, but which maths? Would really like some detail about. Lovely, thank you, Anne. So basic maths such as adding and subtraction. Costings, yes, we've talked about this already, haven't we, Debbie? So costings, trips, materials, time, absolutely. I'll quickly say my sister's working in one of the COVID vaccination centres at the moment, and she can't get over how many people, adults, are coming to the vaccination for a 7 a.m. appointment at 7 p.m. and vice versa. Adults don't know the difference between AM and PM, so we will come to that later. Yes, so sharing, absolutely. So there's lots of skills. So keep having them coming in. I'm going to summarize my ideas now. The first one is relevant and has been already brought in to every calculation. And the remaining bullet points involve application of those 4 rules of number. We need to apply the skills in the list to a context, and we do this in relation to our subject area. So those are the areas that I felt, and you've come up with quite a few of them already. Now compare that list to the general competency framework from the Education Childcare T-level, and you'll see how they link directly to your subject area. Okay, and you'll be developing math skills within the context. And of course, we know that the students are assessed specifically on some of these math skills in the exams. They've popped up in the topic tests and they're in their exams. So we will be talking about those later as well. But before we go any further, I'd also like to ask another poll question. How confident are you in your own math skills? So I'm going to launch this poll and ask you to choose an answer, but don't worry, you know this is anonymous and you're in a safe place. I just really want to get an overview of where everybody's coming from in relation to their own maths, knowledge, understanding and confidence. I'm just going to launch that next poll. So choose the one that's most appropriate to yourself, please. Okay, lovely. I'm just going to close that poll now. So 67% or 2/3 are quite confident, and we've got 33% not very confident. So thanks for that. Thanks for sharing where you're where you're at. And we should also acknowledge that if you're going to develop your students' math skills, you do have to have some confidence in your own skills and knowledge. However, we're not asking you all to become math specialists. You are experienced professionals, and what we are asking you to do is to develop the math skills your students need in industry. All students will interpret and respond to the attitude of their teachers in relation to how much they prioritise areas for development and engage with learning. If teachers aren't positive about maths, this could have a negative impact on their attitude towards it. When I say their attitude towards it, I'm talking about the students' attitude. Okay, lovely. A quick review of place value and the decimal point. There's a large number in words. Would your students know how it would be written correctly in place value terms? We need to consider where all of those numbers sit in relation to the value of each other. In childcare and early years education, this is where children are going to start. So it's important that the T-level students fully understand the concept of place value. I've put that number into the table, which I would need to do if I was asked to carry out any calculations with it. Probably the most tricky number in that whole table would be the 0 that's in the tens column. Would like to highlight the importance of there's hundreds, tens and units. And then there's also hundreds, tens and units of the thousands. And then we've got the millions units. There would also be then hundreds, tens and units of the millions. And that concept of those three place values together is really quite important. We're also going to quickly explore the decimal point. When we normally refer to this, we're talking about multiplying or dividing by 10 or 100, etc. When we say you move the decimal point to the left or right, this can be quite confusing to students. I say this because, referring back to place value, the decimal point never moves from between the units and the tenths. It's always there, it never moves, and the numbers move around the decimal point to the left or right, depending on the calculation. It's quite a small but important point, so please keep it in mind when talking about the concept. I was always taught that you move the decimal point to the left or right, but if a student or a learner is learning about place value, we have to be quite clear that the decimal point never actually moves, the numbers move around it. Okay, so now let's focus on examples of the application of maths in context and to explore some activities that could be used to support some of the specific areas. We're going to start with the foundations and the 4 rules of number. It's important to highlight here that there are many ways people apply and use these rules. We all may have different methods to find the same answer, and we should remember that students might use a different method to us. While I run through these methods, please share your own strategies in the chat box. So let's start with addition. This can be done by counting on from first number on a number line. So in the example here, counting on 5 numbers between 4 and up to 9. Or could jump along the number line for bigger numbers. You could jump the tens, for example. And this is using a number line, but jumping as well. We could also use the compensation method. Sorry, this example here looks for numbers which add up to 10. So the 7 and the 3 and the 8 and the 2 is a useful method for mental maths and then just adding on what's left. And then this is the compensation method where you would add something on to make the sum a bit easier, but then remember to take it off again. There are many other ways to do this, and each individual person will have a strategy that works best for them. Just going to have a quick look in the chat box and see if anybody else has put any other methods, not as yet. Please feel free to share methods that you also know of. So we're going to move on to subtraction and do the same. You could use the number line method again, going the opposite way to the addition. Then we've got the borrowing method, and there's more than one way of doing this, which I've tried to show 2 separate ones on the example. There's also the partitioning method for subtraction, when you use a number line to work out the difference. Breaking the numbers down into units, tens and hundreds. And the complementary addition method is where you use the number line again to look at the differences between the larger and smaller numbers. Again, there are many other ways of doing this, and all we need to do as teachers is know that these different ways exist. Okay, we're going to move on to multiplication now. If you say anything that confuses you or you have any questions, prompts any questions, please pop them into the chat box. Moving on from the normal traditional method for long multiplication, we also have an example here of the grid method, where the numbers are portioned into their place values, multiplied, and then added all together. We then move on to the lattice method, which I particularly like. It uses the table to split larger numbers into their units. So this example, you can see multiplies the 9 by the 6 and then 9 by the 3 and so on, and then adds up the totals in the diagonal boxes to get the final answer. And then finally, if you haven't seen it before, the Chinese method or stick method, where sticks or lines represent the numbers. Where they intersect gives you the answer. But for larger numbers, we need to start off by knowing that when multiplying these type of numbers, 16 and 24, you're going to end up with a 3-digit answer, a number with hundreds, tens, and units. Therefore, we'll have to look at these intersections in a different way so that we end up with a 3-digit number. After we have the 1, 10, and 6 units for the 16, we then add the 2 10s and the 4 units of the 24. We then separate off those intersected areas, as can be shown in the example now, and add up the intersections for the units, the tens, and the hundreds. This gives us 24 units, 16 tens, and 2 hundreds. We then add all those numbers together to get the answer of 384. That was a quick run through multiplication. If any of the approaches are new or confusing, please don't worry. We all won't be experts in all of them. So please talk to your maths teaching colleagues in your organisations if you'd like more information, or be more confident with them with your students, or have a chat with me about them sometime. Okay, the final rule is division. The first method uses repeated subtraction, and this is quite manageable and easy to do for smaller numbers. The second uses an adding or counting on approach, and a knowledge of the times tables is always going to be handy in this example. The third uses grouping numbers, similar to using multiplication. The example here shows how you would identify groups of 9 to show that there are 4 groups of 9 in 36. And this visual representation could be really useful for students who like to see things visually. You could also group them differently, for example, in 8s, and then bring in the concept of remainders, because if we had boxes of 8 there would be some left over. And finally, this is what I would call the traditional method of long division. How comfortable are you and your students with this method? If I was to do this on paper, I'd start off by writing down the 17 times table beside it, adding the 17s together to make things a bit easier. This is also where you might bring in the concept of using zeros after the decimal point. It would depend on how many decimal places the question asks for in the answer. Okay, we're now going to relate maths to the subject area, but before we do this, I'd like to run another quick poll. Research into approaches to maths and English development for vocational learners suggests that specific approaches have differing levels of efficacy. Please vote now for the one you think would be the most beneficial from the options shown. So your options are maths learning being contextualised by maths teachers and being taught by maths teachers, developing the students' maths skills within the vocational context, or collaboratively with vocational and maths teachers working together. So choose which one you feel is the most appropriate and beneficial to students out of those 3 choices. Lovely, thank you. I'll just leave it a couple more seconds. Excellent, thank you for your answers there. So we've got 0% maths being contextualised by maths teachers, 25% developing the students' maths within a vocational context, and then 75% for the collaboration one, with vocational maths teachers working together. Excellent. And all of those answers are correct. It depends on your subject area, your skills of your teachers, etc. This research was carried out by the NRDC quite a while ago now, it's 2006, and I have included the report for this in today's materials section. The research is called "You Wouldn't Expect a Maths Teacher to Teach Plastering," which is a good way of showing that asking vocational teachers to teach English and maths is quite similar to asking maths teachers to teach a vocational area. It's not necessarily their area of specialism, so it's really interesting piece of research. The findings were that using all of these approaches had the best results on the skills and knowledge of the students. As I say, if you'd like more information, you'll find the document an easy and quite interesting read. And as I say, please remember to add any questions or comments into the chat box. Okay, we're now going to use the general competencies framework from the T-level specs, and we're going to start with measurement, GMC 1. This area is detailed and comprehensively covered in the national curriculum as well, and starts in detail at Key Stage 1. Okay, so students are going to need to have a good understanding of the language of measurement. This would include terms such as weight, length, rate, current, volume, concentration, quantity, mass. The list is endless. Lots more terms that they would need to know and understand. They'll also need to recognise and use different units of measurement, and more importantly, when and how to use them in context. We have metric and imperial units, different scales for temperature, units of time, and just to cause more confusion, a range of abbreviations and expressions for the different units. Language and units can cause many problems for students and teachers alike. Then we come on to comparing and converting between units. Exam questions will require students to have a thorough overall knowledge of all of these and be able to choose and apply them correctly to solve a maths problem. These questions could relate to time, and like I said earlier, don't assume that they know the difference between AM and PM, and of course the 12 and 24-hour clocks. Volume and examples of liquids and other substances. Length, both metric and imperial. Weight, as well as interpreting the scales from diagrams. Janet, this is the first time I'm going to come to you and ask for some examples from the subject area where the students would apply and use these skills and knowledge, please.
Thanks, Helen. Yeah, just thinking about that, the first thing that comes to mind for me is thinking about the centile charts. So those centile charts that are looking at weight and measurements with the newborns and throughout those early stages of the first few years of life. There's also lots of activities. I'm just thinking, thinking of the scales diagram that you have there, thinking of looking at plans of different environments, indoor, outdoors, and then interpreting that to a scale. I love the idea of sort of creating spaces like that. And also there's so many activities that look at time. We could be thinking about sequencing of events. We could be, with children, we could also be thinking about things that are measured in time, so sort of looking at something like a baking activity, how long is this going to be? We're going to stir this now for a few seconds, let's be counting that, let's be putting it in the oven, we might use a little timer. So there's all different things that can be done that will introduce it. And I think sometimes, maths might appear, when we don't use it all the time, we think of those skills as being lost, but they're not, they're hidden, and we use them more often than we think. So it's just about thinking how we use these things in activities with young children, or through those routine sort of things like the centile chart measuring and so on. We use maths an awful lot.
Lovely, thank you for that, Janet. We will come back to you each time, so thanks for that. Brilliant. Okay, moving on to GMC 2. As we become more and more technologically advanced, we seem to be more reliant on using technology instead of brain power. Everyone with a phone carries a calculator with them, and to save time and effort, we're human and we'll use what tools we have. It's totally understandable, but we don't always use the technology correctly, and using estimation or checking that the answer makes sense. I see this all the time, and even everyday tasks, it is useful to double check. I've seen a retail assistant use a calculator to add up the total cost of 5 items, coming out with an answer smaller than a single item on the list. In a previous job role, I was paid commission, but my employer couldn't work out percentages correctly. I therefore had to check her calculations and ended up being underpaid too many times until I got wise and ended up telling her how much to pay me. Students need these skills to be effective in their daily life, studies and work. And a massive role for any teacher is to provide a safe space for their students to get things wrong and learn from their mistakes. In maths, 2 plus 2 is never going to be 5. What's more important is creating an environment where the students feel confident that they can explore incorrect answers too, to enable them to learn and get the correct answer. Their previous maths learning experiences may have been negative, especially how their teachers responded to their errors. So an approach which takes this into consideration and allows learning to take place will be more positive and constructive. Okay, the next competency relates to proportion, and in simple terms, this tells us about a portion or part of something in relation to a whole. Students should be able to understand this concept, including how it could be presented, for example, in numerical form or in data sets, in graphs, tables or charts, or as an image as a diagram, and of course, how to interpret the information provided. An example of this would be the school proportion, the proportion of the school population that has sorry, I'm going to take that off a second, that have special educational needs. I did a bit of research, and in England currently it stands at about 1.23 million or 15%. But how else could this be presented? It could be 1 in 8. Which is easier to understand, 15% or 1 in 8? And what are the implications of these figures? Could the students interpret the impact of this on the classroom and a teacher's practice? For example, if a class contained 24 pupils, how many of them could the student expect to have special educational needs? I've also included the question here from the topic test that's currently available, and this should be a simple division task, but do all students understand the language here of simplest form? And probably more importantly for you as their subject teachers, why would they bother to do this? What use would knowing this be in industry? I would think that there would be something around subject specific here related to the importance of knowing it. For example, what proportion of resources might be needed in the sports department for male and female activities. I mean, this is where it would be vital that you as the subject teacher promote the use of maths in the context. This is where I'll come back to Janet for any more examples of where the students would use these.
Thanks, Helen. So a good one there, just taking that word ratios. I'm looking at your example there. So again, students could be thinking about the number, in a scenario, the number of babies and young children that are attending an early years setting. Therefore, how many, what's the proportion in terms of ratio, how many under 2s, how many children 2 to 3, and so on, so that proportion of ratio and staffing timetables and so on can be considered. There's also very simplistic things looking at proportion in terms of a whole, and perhaps even looking at things like snack time and thinking about how things can be divided up and so on. Also, when it gets more complicated, looking at the graphs and tables and charts, you might think about some simple statistics around demographics. So thinking about the reports that we can find quite easily around disadvantage and child poverty and the areas where English targets are low. There's statistics around that to show those examples, and also as well around the outbreaks. I didn't want to mention COVID because I was thinking of more outbreaks of measles and things like that, and there are tables and things that show that sort of proportion in certain areas as opposed to other areas in relation to demographics. So there's lots of examples of proportion and working with proportion that can be very simplistic and quite complicated, but that do that job of contextualising it in education and childcare.
Lovely, thank you, Janet. And luckily, you've kind of introduced my next slide. Lovely there. Looking at proportion in tables and charts, this first image shows the percentage of pupils who attend special schools in the UK. What information could be extracted from this image? What discussion could you have with T-level students about this information? I mentioned the figure of 15% on the last slide. Why did the percentages on here not add up to 15%? The second image relates to the percentage of pupils being classified as having SEN by the end of year 1 in state-funded schools in England. The label on the x-axis tells us the difference pre and post-reform. At first glance, what might that graph be telling us? And again, what discussion could take place around interpreting and using this chart? The next table I'm going to show you relates to the population of the UK. Out of approximately 66 million, how many are actually in England? How might this information be used in your T-level learning? So you can see from this table that it shows that England has 56 million of the 66 million of the population of the UK. And this gives a breakdown of the number for each of the countries. And these charts show the exact same information. Questions about these could be about ease to read and understand, what each gives us on an individual basis and how they might be used in the industry to work with proportion. So a lot of discussion around what actual information you get from these different types of charts, especially when students are going to be expected to present numerical information themselves as well. How might they do it? Janet, is there anything else from the subject area that we could mention for ratio and proportion?
I think considering everything that's been said, Helen, it's about having that confidence in interpreting, and using some of those skills, interpretation of what information is being shown on the tables, and feeling confident with that, and then sort of from again building up and thinking back to the wall and building up those skills as you quite rightly described. Simple things that can be done with young children where you're just sorting, you're classifying, you're making tally charts. Those sorts of things also help with a very sort of foundation for looking at this sort of thing and developing those skills so that you're able to apply those skills to something that may at first look complicated in terms of interpretation of a chart. So simple things that can happen in the world of education and childcare, such as a tally chart, such as sorting, how many green cubes do we have, how many round beads do we have, and so on. You're going to get square beads, but colours, I'm thinking. And then you're actually able then to make some sort of interpretation, and you're developing those skills and building that confidence rather than going in at the top of something, starting with something that's quite simplistic and contextualised, helping to bring out these skills and develop that confidence.
Wonderful, thank you. And this data here shown isn't necessarily in isolation. I would also encourage students to remember these facts and figures and apply them to make sense of other problems. I'll come back to that later. Okay, we're now going to move on to using rules and formula. And this is an area that teachers and students can sometimes struggle to see the relevance of. But there are many ways in which they can become real, including in business and finance, especially for compound interest, billing purposes, examples, which could be used in utility and mobile phone network charges. In DIY and gardening projects, considering the rules for calculating area, perimeter and volume when you're painting and decorating, for example. And also for cooking, easy one, carrying out calculations when the cooking time is reliant on the mass of the item being cooked, and also ratio to make more or less of an item from a recipe. And again in health, when calculating body mass index or medication reliant on weight and age, etc. Janet, again, is there anything that I've missed that you could bring in some real life examples from the subject area again?
I think there's lots of things, again, just through those activities and simple things that can be done in class that you would enjoy, that students would enjoy, that they may be seeing or will see when they're in their placements. So baking, we've mentioned, the idea of cooking, we've mentioned, but I also think looking at things like measuring, weighing, sand, we could look at water in terms of volume. There are lots of things that can actually be made. Somebody said, didn't they, in the chat, making us fun. And I think, if you start with that, you can't go far wrong in terms of that contextualization. But then you have to take it to that serious level of, well, how was playing in the water mathematical? How was baking mathematical? And then you're looking and bringing together all of these different skills. So there are lots of opportunities. I'd say those typical core areas within an early years setting could be investigated by students to think, how could this introduce early emergent mathematical skills? And you could think about the water area, you could think about sand, you could think about construction, and there'd be lots of different ways that actually you could look at that with through a mathematical lens.
Lovely. Thanks again, Janet. Some smashing ideas again. So moving on to processing and understanding data, and this is where analysis of the information provided is really important. So strong evaluative skills and awareness of maths processes are needed to effectively interpret data, to evaluate where it comes from and the reality of its impact. This links to the saying lies, damn lies and statistics, as students need to have the ability to assess data and its reliability. This leads to the interpretation of data, evaluating and questioning it, and then also using the data to inform any decision making. Which leads us to an example of this in practice. Imagine you've been offered an entry-level role by 3 different companies. Company A's average wage is 40,000 per annum, with B's being 82,000 per annum and C's being 55,000. Which company would you choose? Please pop your answer into the chat box. Would you choose company A, B or C based on the data I've given you so far? Lovely, thank you, Anne. I think I would too. Choose B. Thanks, Debbie. Wonderful. The answers are coming in. And at the moment, I have put you on the spot and I haven't given you very much information to base that on. So I'm going to give you some more information now. So the next piece of data relates to how many employees each company has. Does this impact at all on your choice? Next, I'm going to share what the modal average for each company is. It differs, as you can see on the screen. Does this help any further with your decision making? And finally, I'm going to share the range of data for each company. Does this tell you anything useful? We talk about range, highest takeaway, lowest. What does that actually tell you in relation to the importance of the data that you're being presented? And lovely, thank you for your answers coming in, that's great. Okay, you're now going to be able to see all the company's wages, with the figure at the bottom being the wage for the entry-level role you've been offered. You'll note that when I gave you the first average, the highlighted figures, I didn't share which average it was. Would this be important? There are many factors which impact on data, and this is made use of on a regular basis. But probably the most useful piece of information here would be the range. The range tells you about the spread of the data being presented and therefore its reliability. The larger the range, the less reliable the data is. Janet, again, is there anything else from the subject area that you could apply?
Just thinking you could do a similar sort of exercise. You could look at occupational maps. You could look at, you know, the pay and so on, and you could do similar things like this. Mm-hmm. In terms of practical activities, I'm not sure. I'd have to give it a little bit more thought. But what it does do is actually, it does make you think. It's that critical thinking around mathematics, this one, I think, Helen. It's Absolutely. Certainly making me think. When you put the question up at first, I thought, I don't know, I need more information, and I still need to give it more thought. So maybe it's just too much for me to take. I don't know.
Well, this example demonstrates how you can manipulate figures to suit.
Exactly.
When I said the average wage at the start, it was the mean average, where you add all the numbers together and divide by how many numbers. But all of these numbers differ, yet all of the starting level wage is identical. You could choose any one of those. They're all the same. So it was just an example of how data can be used in a manipulative way by the person presenting it. Which leads us nicely to interpreting and representing mathematical diagrams. So I'm going to show you some more diagrams here. This first one relates to a scale drawing. Going back to DIY and or decorating, students could be able to understand how the scale relates to the dimensions in real life. The second, I know we said we weren't going to talk COVID, but the second diagram relates to the COVID-19 vaccination program. What might this graph be telling you? It's got numerical values on the y-axis and dates on the x-axis. So is this graph showing cumulative data or discrete data? Students should be able to confidently review this type of data and what it represents or means. Questions for discussion could be around the rate, changes over time, and the implications of them. The third diagram brings in more detail. What might the colours represent? Thinking back to what I said earlier about related to the UK population, could that help? This final diagram includes a label at the bottom, and you can see that the vaccination programme data here is split into the 4 countries. Does the vaccination programme fit with the population of the different countries when you think of that 56 million living in England and the remaining 10 million being in the other 3 countries? Making this type of activity relevant to the subject area is vital for engagement, but students would also benefit from looking at other contexts to broaden their understanding and confidence. Janet, I'm going to come to you one more time. Is there anything about data that you could use there for education childcare?
Yeah, I mean, this is a very good example, Helen, and you could do something very similar with looking at sort of family hubs and how family hubs are being sort of distributed across the UK. And so you could look at fair sort of access for people across the country and so on in terms of children's services. So that would be something that you could really look at. You could also look perhaps at the different ranges of early years provision, you know, so looking again, maybe in local authority areas, within your own local area, how many childminders are listed on the registration, how many private nurseries do we have within this sort of local community, how many private nurseries and so on, how many schools. So you could have a look at the different types of children's services available, and you know, include things like statutory, private, voluntary, independent. So you could have a really good mix. So it would be a nice little sort of researchy task. I can see a group of students really enjoying looking at the services that are around within their local community or within the community that surrounds the school or college that they're studying in. And that would give a really good mix for sort of, oh, you know, this is what's available here. Now let's compare that with another region, with another community, and what's that comparison looking like? And that gives you some really rich information. So that would be something I think that could be quite fun and quite engaging.
Absolutely, totally agree. And what's really good is you're developing the students' discussion skills at the same time as developing their math skills and their subject-specific knowledge awareness. So it kind of ticks a lot of boxes, doesn't it? And really, you look for things that are really going to be engaging for the students to talk about when they're actually going to be using maths skills and knowledge as well. So yes, puts everything together, doesn't it? Yeah, lovely. Thank you.
Does. And I think you can also explore things like equality after that. You know, you're really bringing together that wider understanding of education and childcare. So, yeah, it can be a real catalyst for further learning, I think.
Absolutely, totally agree. So we're now looking at communicating using maths. Please consider when this might take place in industry and pop your ideas into the chat box for Janet and I to share and talk about. I'm going to give you some generic ideas which could be contextualized, and these are shown on the screen now. This could include time and motion reviews, report writing on work carried out, supported by data, and analysing work processes using data to inform it. For example, as Janet said earlier, ratios of people, customer satisfaction data, or a review of spending. Anything in particular communication-wise that we could share about maths and education childcare? So while Janet and I wait for some ideas to pop into the chat box, Janet, is anything you could highlight as being something for communicating using maths? I was thinking managers obviously are more likely to be using maths in their communication, do you think?
Yeah, they will. They'll be looking at sort of ratios. They'll be looking at staffing requirements. They'll be looking at budgets perhaps, and planning that over the term, and also thinking perhaps about just resources and sort of that type of thing. But also, I think all early years professionals will be looking at this. They'll be looking at their observations and moving forward those checkpoint observations, and they'll be writing reports. So they need to be able to have a good sort of overview of how the children are doing, how their key children are doing, and so on. Also, in all kinds of planning, I think you're thinking all the time. You mentioned, we've looked at time, we've looked at resources and availability and so on, and so that's a key skill, and thinking about when's a good time to introduce an activity, not necessarily just before you've got a set structured time, so lunch might interfere with it, or children are not going to be able to enjoy that because it's coming towards the end of the day. So all of those types of things, I think, are part and parcel of everybody's life as an early years practitioner.
Brilliant, thank you. And moving on, probably the easiest one, and one we've already been talking about in the chat box, is relating to costings and finance. Students could carry out a costing project which would require them to use every math skill and competency area we've already covered in today's session. So things that Janet has just spoken about then, but really focusing on the math skills needed to cover all the areas that are currently on the screen now, and comparing, converting, applying for funding. How much funding do you need? Where does it come from? How do you get it? And then the impact of spending and how effective the spending processes have been. So costing a project would be a lovely overall project for students to work on in context, but also using all of their math skills. And then finally, we come on to optimizing word processes. And again, I put some examples on the screen now, but I'm going to go to Janet for some specific education and childcare work processes that might need to be reviewed using maths.
Okay, so I think, again, looking at the effectiveness of how resources are used. So observations and longer observations are often used. We hear of time sampling or observations that actually record how often a child might play within a particular area. So we're looking at the effectiveness of that resource. Nobody's going into the role play area, or when they do, children are just trashing this and not perhaps using it as you thought, as you intended. What can we do? So it gives you an idea. It's not so much time in motion review, but it is about effectiveness, and it is about looking at how can we improve that, because this particular area is not being utilised and maximised, or perhaps it's only being ever used by a certain number of children. How do we engage other children in that? What else can we do? So there are ways of looking at things like that, I think. And also in terms of sort of managing budgets, what we were just looking at on that previous slide, and here with the costing of resources and so on, just thinking about something that's almost like a magical mirage at the moment, but planning an outing with young children would cover all sorts of things that would bring some of these skills together. How many children are we inviting? What's it going to cost? What do we need to take with us? How much of that do we need to take with us? How many adults do we need with the age of the children? How are we going to get there? How long are we going to stay there? How long is it going to take us to get back? All of these things would really help, to be able to, and you can do it fictitiously, of course, with a scenario, but it would be good to actually engage with something like that in real life to see how those sorts of things are pulled together. And they're very important, critical things, from posting a letter to going on a full-scale outing with children. There are mathematical concepts that need to be engaged all the way through.
Absolutely. Thank you, Thank you for that, Janet. So what I've got here are some of the questions from the topic tests. We're not going to run through them, but these are examples of the math skills that students would be expected to use if you haven't seen these. And I've also added a resource in the materials section today to support your students' development of these areas in particular. So I have been asked by a couple of centres about the maths questions. So you'll see the type of questions that we have in the topic tests. But as I say, also there's a resource in the materials section which supports you to support your students to be able to answer these questions. But what I would like to say is the most important thing that you do as specialist teachers is engage the students in why you would want to know, why you would need to answer any of these questions in the context. That's vitally important. The actual maths skills, you need to talk to your maths specialist colleagues or us for advice and guidance, but it's down to you guys to promote how important the maths skills and knowledge that you would need to do these would be if the students are going to be successful in industry. So we haven't had any questions come in. I'm just going to run through the rest of these slides and encourage any questions, please, to pop them into the chat box and we'll pick them up. We've got 5 minutes or so left, so I'm going to run through the last few of these slides while I ask you to put the questions in. The first and most important thing to do is to ask about your takeaways. Please consider what, if anything, you'll take away from today's session and possibly how you could use it, how you could utilise that new skill or new piece of knowledge, that little pearl of wisdom that you've picked up to develop your practice. And then always the normal action planning, remembering that to make any CPD meaningful, it's not just about attending the session, it's all about how you're going to action any learning from the session. Please consider how you might use it to inform your practice and probably set yourself a couple of action points or action targets and deadlines which you can use to take away and help you to continue to develop your teaching and learning practice. On the screen now, you'll see what we've got planned for the coming months. And we're really looking forward to working with World Skills UK. We'll be delivering sessions in collaboration with the World Skills skills coaches and the staff. And please remember that all of our webinars are recorded and made available to you after the event. I've also included the links to the log in to the registering for the events and the recording of events, but also a couple of websites that you can find some English and maths resources to help you with those as well. So when I send you this PowerPoint for your review and information, you can have a look at those as well. And the external resources obviously are not NCFE resources. The Skills Workshop and the BBC SkillsWise and Bitesize sites are external, but they are quality checked and they have some really good ideas that you could adapt and use. So all I've got to say at the moment is keep sending questions. If you have any questions, please pop them in the chat. I want to thank everybody so much for attending and participating, especially in the polls today. You will be asked to complete a quick evaluation as you log out, and your feedback and ideas really do help us to develop our CPD offer. I'm going to say a massive thank you to Janet for her expert input as per normal.
You're very welcome, Helen. And just to say to everybody, you know, maths, sometimes it feels a bit scary, but if you think about those different, I'd take it down to those sort of grassroots, what's going on in an early year setting, work then with your maths teachers and think, okay, this is what's happening in an early year setting. I need now some problem solving type activities that I understand that I can share with these students to help them through the activities and the experiences that I can offer in the classroom environment. That way it won't be scary, it'll be fun, and they'll also be learning those mathematical skills.
Absolutely, and we have had suggestions from participants today that the more fun you make it, the more engaging it's going to be, but it's also going to be more fun for you as well to deliver and less scary. So please keep doing that, and also try and engage your employers in promoting English and maths in the workplace as well. And the students could even have a task where they go looking for English and maths and possibly IT tasks that they would do on placement that they would need to do to be effective at work. So as I say, those are the links to the T-level support pages and the websites that you might find useful to support English and maths skills development. No more questions come in, so all there is to do now is to say goodbye. Thank you again for attendance, for spending your precious time with us today. Hope you found it useful. And for everyone at NCFE Cash, please stay safe, and we always look forward to working with you again. So thank you. Thanks ever so much.